I toggled.
Cool. Hi, everyone. It's Marley and Mily. So, unfortunately, Michael can't be here. And so we are doing what he would normally do, which is bring us live to YouTube and Facebook. So, my name is Marley. You all know me. But today, kind of playing host is my coworker, Mily. Mily, introduce yourself to all the people.
Hello, everybody. My name is Mily. I'm filling in for Michael today as the co-host here at Ask an Astronomer. And I am the multimedia producer at the MacMillan Space Center. And I'm also a scientist and science communicator and a filmmaker. So I do a bunch of different.
Millie wears a lot of hats here, is what I've learned. We've started doing this thing called Space Jams that's actually on this YouTube channel that you can check out if you'd like and see what we do there. It's kind of a little video short of their different themes of the month here at the Space Center. And Millie writes and produces and directs all of them and tells me kind of what to say and what to do. But today I am here to talk about a really exciting mission that's about to go ahead, supposed to launch in the next next week, Juice at the mission Juice, which is going to be on at Jupiter. So that's what we will be discussing today, Millie and myself. Millie is watching the chat. So if you have any questions on Facebook or on YouTube, you can throw them into the chat and Millie will be able to see those and ask them to me as we go throughout this presentation here. So Juice at Jupiter. This mission is put on by the European Space Agency, and it is a satellite that will be, or a spacecraft that will be traveling to the planet Jupiter, but specifically its moons. It is the Jupiter Icy Moons Explorer, and that used to be an acronym, but then they changed it to just JUICE, the Jupiter Icy Moons Explorer. So not really like a great decision, but something that they just chose to do, I guess, with that. Its mission is to look at the five main mysteries of Jupiter that we currently have. So one of them is, why is Ganymede like that? It is a really, really unique moon. For whatever reason, it's actually the largest moon in our solar system. And also focusing on what are ocean worlds like. You know, out of Jupiter's closest moons, the Galilean moons, the three of them, we are pretty sure harbor a subsurface ocean. And so what kind of world would that be? What world would that look like? As well as following that, could there be or has there ever been life in the Jupiter system is another question that we have. And what's up with gas giant planets anyway? Like Jupiter is going to become, and its environment around it is going to become this stand-in for all gas giant planets that we can find. It's the closest one we see. It's the closest one to us aside from Saturn. And so it kind of acts as its own little solar system. And so if we can understand Jupiter, we can understand, you know, other planetary systems like it out there, different exoplanet, different systems, how these gas giants form, what really goes on with them, what their cores are made out of, things like that. And as well as studying how has Jupiter's environment influenced its moon. So Jupiter's environment, I recently learned, and I think most people will recently learn with this mission, is that it's actually quite not violent, but just quite extreme. It's a very extreme environment out there on Jupiter. But specifically, being the Icy Moons Explorer, JUICE will be looking at those icy moons. So that is Ganymede, Europa, and Callisto, these icy worlds of Jupiter. And Ganymede is starred in this slide because it has the primary focus. It's the primary target for the entirety of the mission. Europa is the moon that we're most familiar with, I think, in terms of images, in terms of knowing about this moon. It's quite a famous one of Jupiter's moons. But you'll notice there's only 2 flybys of the spacecraft planned for this moon. And that's because the radiation environment around Europa is extraordinarily harsh. And it has a lot of potential for damaging spacecraft electronics. And really, it has its own mission coming, right? There's the Europa Clipper mission that's in development. And so we don't need to spend a ton of a time on Jupiter, because Europa, because science will follow for this moon. The closest approach will be about 400 kilometers from the surface, which is pretty close. And the main goals for JUICE as it flies by is searching for biosignatures, pockets of water, and just exploring the geology, surface, and subsurface activity and environment of this moon, right? Seeing if perhaps, you know, it has some sort of biosignature that could suggest that maybe there's life in that underwater ocean that we believe to be there. The second icy moon, Callisto, this is actually the furthest moon out of the Galilean moons around Jupiter. It's the oldest surface in the solar system. It's heavily cratered and very inactive. And so studying it would kind of tell us about what the early Jovian system looked like, what was going on in this time when these moons were forming, when Jupiter was very young, what that environment was like. It has 21 flybys planned with a closest approach of 200 kilometers, which is much closer than Europa. The radiation environment out here isn't as extreme as it would be closer to Europa. So we're able to stay a bit longer and get a bit closer. And finally, the primary target of Ganymede. So this moon looks a lot like our own moon. I always get tricked at first when I look at it, thinking it's our own with its geological surface. And it's the geological surface that is particularly interesting. It varies a lot, right? We have cratered regions. We have mare, kind of like our own, where lava may have cooled. And because it's varying, it gives us a geological record spanning billions of years. So some places are much younger geologically than others, as opposed to Callisto, where most of the surface of the moon is very old, and Europa, which is constantly regenerating and has a very young geological surface. It has 12 JUICE flybys planned, which seems very few for it being the primary target, but this is because ultimately JUICE will enter orbit around Ganymede and stay in orbit around it and study it. Closest approach during flybys about 400 kilometers and then 500 kilometers while it's in orbit, though they are aiming to get to 200 kilometers. I'm not quite sure how they'll accomplish that because it's the only moon with an internal magnetic field. So it generates its own magnetic field, much like Earth does, which is very surprising. It's the only moon we know that can do this and does this. Which is partly why it is so interesting to study and why it's been selected for priority. And speaking of the magnetic fields, I have this video I wanted to show. I tested it with Mily a few seconds ago, and it kind of started out odd, but we will see what happens with it. It's from the European Space Agency, and I think it just doesn't like being included in a PowerPoint. But what it shows is a very simplified interaction of magnetic fields of the moons. So if I pause it for a second, the blue magnetic field lines, or the purplish blue, are coming from Jupiter. And this is the moon Callisto. Callisto, the outermost moon, it has an induced magnetic field. So it doesn't create one of its own. Instead, the interaction of Jupiter with the subsurface ocean as the moon moves through the magnetic field of Jupiter causes it to have an induced magnetic field that looks very, very different. The second moon that we see is going to be, zoom in a bit, Ganymede. Now, Ganymede is the one that has its own magnetic field. And so when it interacts with Jupiter's magnetic field, we see a lot of very interesting things begin to happen. So its magnetic field becomes a combo of this induced magnetic field as a result of Jupiter's own field interacting with Ganymede's intrinsic field that it has itself. And you get to see these aurora. These are those blue rings on the planet. You see them on Jupiter's north and south pole. You see them on the moon kind of at different latitudes, the mid-northern and mid-southern latitudes. They move spots because of where this magnetic field ends up, right? So aurora are caused by high energy particles following magnetic field lines and interacting with the atmosphere and different gases with them, at least on Earth. And so we get aurora in Ganymede just on different latitudes because the magnetic field becomes so changed and misaligned and stuff. So we end up seeing something very, very different on Ganymede because of its own magnetic field. What is very interesting as we move from Ganymede. I think our next one, I don't think we go to Europa. I think we do. Okay, so we go to Europa. Europa again has a very interesting magnetic field going on. It doesn't have its own magnetic field. It's being caused by moving throughout Jupiter's magnetic field, and something to do with its subsurface ocean will help generate where that magnetic field ends up. And finally, with Io. Io is interesting in a different way. I know this is the Icy Moons Explorer, so that means Io gets kind of like casted out. It's like the one not icy moon. It's very volcanic. It has vertical magnetic field lines, which connect to Jupiter. So it basically has almost the exact same magnetic field direction as Jupiter does. Io is interesting because it also has a thin sulfur dioxide atmosphere. And that sulfur dioxide atmosphere creates like an ionized plasma around Jupiter, kind of following where Io's orbit ends up being. And so you have this very interesting environment all around Jupiter, right? You can see the ring of plasma following there. And now the video will just zoom back out and kind of show the Galilean moons and all of the different regions of Jupiter's magnetic field lines and stuff like that. And so that really just highlights how strange of a place Jupiter's environment is, which I don't think we think about as much because the Juno mission is so heavily focused on Jupiter itself. But when you start to pull back and look at the entire environment around, you end up seeing some pretty interesting things going on with the entirety of Jupiter. Which means there's lots of science that we can do there, right? With everything going on. So don't worry about all the words on this. It's just a really great graphic for me, and I'm biased towards it because I like it. But JUICE will have 10 instruments total, 9 European partner-led. One will be by NASA, and a couple of them have hardware built by the Japanese Space Agency. So very much a collaborative effort going on inside of this spacecraft. Of these 10 instruments, 4 are remote sensing instruments. So that's like a camera, a spectrometer, a spectrograph, those sorts of things. 3 are in situ instruments. So that means they'll be using like actual particles and stuff mostly as they're flying around. So study the magnetic field. I can't pronounce the word. Magnometer. Study the magnetic field, something to study the different particle environments, and something that studies the radio and plasma waves as it moves throughout the moons. The other 3 are geophysical instruments. So that's radar and altimeter to get the height and the altitude of different things as it maps the surface of these moons, as well as a radio science experiment. There's a second experiment, or one actual experiment, called PRIDE, which is a radio interferometer and Doppler experiment, and one radiation monitor, which kind of comes near the end, but it's actually incredibly important as the radiation going on in this environment is extremely challenging. There's a lot going on. We have the high radiation. We have a very far distance from Earth. We have very weak sunlight. The sunlight that will reach JUICE by the time it's at Jupiter in the environment is 25 times weaker than on Earth. So not a lot of power to be had at all. It is going to encounter a lot of heat as well. We can't just do a straight shot from Jupiter, from Earth all the way to Jupiter. We need to garner a lot of speed, and we do that by using gravitational assist, right? Or like sometimes they're called slingshot maneuvers. And part of that is a flyby of Venus. And when around Venus, JUICE will get temperatures of positive 250 degrees Celsius and cut out once it gets to Jupiter to negative 230 degrees Celsius. So there's a lot to consider with the challenges of a mission like this and going this far. And they've come up with solutions like shields for the radiation, a very long antenna, and an advanced computer that can do some problems on its own, as well as solar panels that are about a third of the area of a tennis court to be able to collect a lot of sunlight while it's out there, and new types of insulation to help keep the internal temperatures of the spacecraft warm. If the outside gets hot or cold, it's not, it's manageable with, but really we want the inside, like where all the experiments, where all of the scientific instruments are, to keep an internal temperature stable, to keep it in a certain spot. This is a map of the flyby. I'll pause here, Mily. Are there any questions that have come in at all?
Not that I can see on our restream here. I had a question about the magnetic fields, though.
Yes.
And also talking about radiation, because the magnetosphere of our Earth protects us from radiation. Is JUICE going to get close enough to the moons where the magnetic field kind of envelops it and protects it from that radiation? Or is it going to be too far out to really be encapsulated by those magnetic fields? And would they even bounce the radiation in the same way that our Earth does?
That's a really good question. I didn't look at how far they extended. I know this video was a very simplified video, so I don't think the distances are accurate. But Jupiter's magnetic field, like it goes out all the way to Ganymede, right? Because it influences all the way to Callisto. So while JUICE is flying around, it's inside of that magnetic field, right? Already,
cool.
right? Kind of like how Earth satellites are inside the magnetic field. It's just like the further out you go, the weaker it starts to drop off. I think it follows distance. I remember one of my friends who did her PhD saying like the worst question you can ask someone is to explain the magnetism of something.
Yeah.
And I'm very much reminded of that in this moment.
But well, we know mostly how our magnetosphere works, but then there's still some things that we're like,
yeah, there's still some parts where it's very confusing. And so I'm sure they've accounted for it, like they would have to, I assume. But I don't know if it'll ever get to a point where the magnetosphere will protect it from the radiation. I think the biggest worry is whatever that ion plasma is going on by Io. Like that's going to be, I think, probably the worst of it. And it'll get not as bad as it goes off. It's just, especially by Europa, like I think the closer you are in, the worse the radiation is. And so when you get to the further moon, like Ganymede and Callisto, it starts to drop off and becomes a bit more manageable, which is why I think they've only planned for 2 flybys of Europa and then more at the outer moons, just to make it easier on themselves and not have to, beef up that spacecraft as much, right?
Yeah.
Because it's already quite large itself.
Yeah.
All right, so this was the flyby just to show us where we're going. So this looks complicated, and it is. There's a lot of moving parts, right? So we want to go launch from Earth and garner enough speed to be able to get ourselves to an arrival at Jupiter. This path that they've chosen is going to take them 8 years. So it's an 8-year-long travel to be able to get to our destination. JUICE should arrive at Jupiter or the Jupiter system in July of 2031. So we have quite a long time. But in that time, as it's going about trying to garner enough speed to get up to be able to get to Jupiter, we have an Earth flyby, 3 different Earth flybys during the journey. The Earth-Moon system in August of 2024, one of Earth in September 2026, and again in January 2029, right? So it does like this loop around Earth, right? Around the sun, a heliocentric orbit, so it can get enough speed before it's able to launch itself out to Jupiter. That lunar Earth flyby has an asterisk by it because it will be replaced by an only Earth flyby if the spacecraft ends up launching after April 18th. So currently it's scheduled for April 13th. But if we get pushed out past April 18th, it'll only be an Earth flyby because of the movement of the moon and where the moon ends up and the gravity they need to be able to move as fast. Gravity is very helpful. It gives us a push whenever we need a nice little boost, but it can also cause a lot of problems, which is why they have to consider all the different moving bodies, right? So Earth, you have to consider the moon as well when you're we see this with the Artemis missions as well. There's only certain windows based on where the moon is around Earth and the different timings that you can have based on entry and exit when you're orbiting an object. These are what we get to look forward to now, all of our mission milestones for the 8 years we have to wait. So we are currently right before the launch on Ariane 5. It's launching on an Ariane 5 from French Guiana. We are waiting for an April 13th launch, is what they're aiming for. So far, it seems like that's the go-ahead in 1 week. JUICE will fly by Europa, Callisto, and Ganymede a total of 35 times. And then the mission controllers will take advantage of Jupiter's gravity and steer the spacecraft into orbit around Ganymede around December 2034. And it'll stay there until about September 2035. That's currently the slated mission end for the spacecraft. And its planned mission end is to fly into Ganymede. Like this is a very common thing they do with spacecraft is they fly them into whatever we are orbiting and destroy them that way or launch them into the sun. But we're a bit too far for that option. This is our launch and deployment timeline. So this may look familiar because they had a similar one when the James Webb Space Telescope launched, because that was also on an Ariane 5 rocket in French Guiana. About a week before launch, JUICE is placed on top of the Ariane 5. This was done on April 1st. About 6 days before launch, JUICE becomes encapsulated in the fairing. So the nose of the rocket drops down on top, is installed on top. And then we have to look forward to the rollout of the Ariane 5 with JUICE inside to the launch pad, and then a launch at April 13th at 5:15 a.m. Pacific time, which is brutally early. So I don't think I'll be able to watch this one. And then we have, of course, spacecraft separation. ESA assumes control of the spacecraft, and then solar array deployment and deployment of antennas and all of the different things that need to deploy to make the spacecraft successful as it starts its 8-year journey on its way to Jupiter. And to end here, I have, they released some images, the European Space Agency, of what this looks like. Because I was talking to Mily earlier today about how I always forget how big spacecraft are until I see a picture of a spacecraft near a person. And then I remember how large these things are. So this is from April 1st, when JUICE was lifted into the air and installed on top of the Ariane 5 rocket. So that's what these engineers are doing. They are installing it onto the launch vehicle adapter, which is a segment that goes like rocket adapter and then JUICE on top. It's bolted down to secure it before the launch is able to go ahead. And then we have, this is kind of fun. This is when it's encapsulated inside the fairing or the nose of the rocket. So if you look at JUICE now, it's missing those red bars or those red plates that were on it before. Those red plates were to protect the solar panels during installation and stuff like that. And so now they've been taken off because we need them off for when this thing goes to space. And it's been installed. That's what these two engineers are doing down here. They are finishing installation of the nose capsule on top of the spacecraft. And I just love their rockets. They always have like a fun little design on them. This was also done on JWST. The ESA rockets always have a nice little painting on them, which I like. But shortly after launch, the fairing opens up and JUICE will separate, and then it's kind of beginning of the mission, beginning of the flight. So where can you watch it? If you're up that early, at 5:15 a.m., you can watch it on the ESA Web TV. They have, similar to like NASA TV, they have their own that will be playing it. There's also going to be a YouTube live stream of the event when it starts. It'll start at around 4:45 a.m. Pacific time. That's when, it starts the launch program. I think not quite fueling, but some parts of fueling, just getting ready for countdown and for launch. Will start, and that's from 4:45 to 7:05 is the launch, and then from 7:30 a.m. until 8:15 a.m. we will have our post-launch press briefing, which will be, I'm sure, fun. Hopefully it all goes well, right? Because that'll make for a good post-launch press briefing. I imagine if it doesn't go well, this might get pushed, just in case, so they can figure out what's going on. But I forgot to mention something all the way back here, and that is, one of the big concerns about when we send spacecraft out into space, especially to explore other worlds, is the possibility of contamination, right? So this JUICE was in a clean room, and then it was moved to be installed. But in there, they have a whole launch kit about this mission, about all the different things that are happening. In the launch kit, it says that JUICE was not sterilized, so it wasn't cleaned, which I found surprising because usually they do that. And the whole reasoning was that the only moon that they are considering that could possibly have life on it is Europa. And they are confident that they will not be near Europa for long enough or get close enough to Europa for any Earth germs to get onto the planet, right? There's a very low chance of it colliding with Europa and bringing anything from Earth onto the moon. And for Ganymede, it's not marked as in the same way as Europa is in terms of when it comes to life, because we just don't know as much about it. But if it does come the point that there is a possibility of life on the moon, and it reaches that status after studying it, then they're still confident that crashing it into the planet, all life would be killed in that event anyway. But it may be reevaluated, which I thought was very neat, because I always thought that every spacecraft got sterilized, but I guess they don't always do that.
That actually leads really well into one of the questions. I opened up YouTube because the questions aren't going to the restream.
Okay.
But Pride has a question, which I was also wondering as well. Does Ganymede maintain an atmosphere?
Yeah, so I also had that question, and I don't think I could find an answer. Like, I don't think I was able to find an answer for that. I don't think it does. And if it does, it's like very thin, because it has that magnetic field.
Mm-hmm.
Oh, yeah, there's evidence of a thin oxygen atmosphere around Ganymede, but it's very, very thin, similar to like the thin sulfur oxide, whatever's going on Io, which like bodes well, I guess, for life, right? There's an atmosphere which can help protect from some radiation, but it is just so, like, it's very thin. But yeah, it's like, it really is like a large moon, small planet, you know, like, what is our definition of this interesting world, which makes sense why it became marked such high priority, right? There's so much going on with it, but it's very, very cool.
And then we had another question. Io is the moon with the most volcanoes, correct? Keith was wondering about the volcanoes.
Who's wondering about it? Sorry?
Keith Lim.
Oh, Keith. Oh,
on YouTube.
I thought you said Keenan, and I was like, Keenan should be working.
We have an interpreter named Keenan here.
Yeah.
Maybe he's tuning in too.
Maybe. No, it's the moon with the most volcanoes. It's not, I don't think it's the most volcanic body. Actually, I can't remember now. But yes, it is the moon with all the volcanoes on the surface. And they're like, they're still erupting. Like, it's very active, a very active surface, which makes it interesting, but disqualifies it from being an icy moon for Juice to explore. Take a different mission to go over and do that.
Pride is also saying could be a sign of plant life. I think they might mean the oxygen on Ganymede, which is oxygen is a biosignature along with like carbon dioxide, and so
I think though that the oxygen atmosphere is coming from the ice, right? Because like Ganymede is it's not just like ocean, it's like an underwater ocean. Like on this slide, this is actually a cutaway of like what we think Ganymede looks like. So like some sort of core, a mantle, very like, this is very similar to Earth, which is kind of weirds me out a bit. And then an ice mantle, which I thought was interesting, and then some sort of ocean, and then ice. And so something going on with the ice, if it's like has an oxygen component in it, is what's creating that oxygen atmosphere, as opposed to life, right? And this is also like really important when we think about biosignatures, is also eliminating what else could be causing them. So we see that, like, I think most recently, like phosphine on Venus, right? In the Venus atmosphere is like, oh, it's a signature of life, but what other things could be creating phosphine? And we see that as well with methane, because methane can occur naturally, but in certain quantities, it tips over to having to have a biological component. And so I imagine very similar to conversations will happen with Ganymede once that information starts rolling in the very not so distant 2030s, but it feels very distant anyway.
Yeah, I wonder if they'll find something like cyanobacteria, like something very, very tiny and small, but could still, produce some oxygen.
Like, it's interesting because the European Space Agency like makes a point of saying that Juice is not searching for life. It's not looking for life specifically. It's looking for biosignatures, but that's not its whole mission. It's kind of not what it's built for. It's built for like all these different 5 questions, like more so characterizing the environment and learning more about what the environment is, because I think we can really only search for life once we understand the environment that it would have to appear in. And we don't fully understand this moon at all. It's a very odd moon. And the whole environment around Jupiter is just completely different from what we see close to us here on Earth. So it's more of a characterization than anything else, than like a perseverance type search, right?
Yeah.
Just a different thing going on.
Very cool.
Awesome. I think I'll stop sharing because we're almost done. It's almost 1:30. You did it, Mily. Good job.
Yay!
But if there's any last minute questions, I'm not sure.
Let me check back over, or that small amount of oxygen could fuel life, Pride is saying, back
yeah.
onto YouTube.
That'd be interesting. Yeah, if it's somehow
Yeah.
able to sublimate back into the is that the right word? Get back into the water, the saline ocean, right? Kind of because fish use oxygen to be able to breathe, right?
Yes.
All right. Well,
All right.
it will be back in 2 weeks, not with Michael though, and not with Mily either, actually. It'll be a whole new person. I will still be here, but we will see you in 2 weeks. And thank you for joining us on April 6th, Ask an Astronomer featuring Mily. It was very fun. Thank you so much.
Thanks.
All right. Take care, everyone.